My name is Saket Kumar Singh. I am working as an assistant professor in Department of Computer Science Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today in this lecture we are going to see what is your file system implementation. In our previous lecture we have already seen what are those file system infrastructures, what are file system interfaces. Okay, what is the definition of file, what is the introduction of file, how many types of files are there, what are different access methods for accessing different kinds of files, how we can apply protection and security to those files. In this lecture we are going to see what is your file system implementation. Okay, so in this lecture the outline will goes like, first we will see about file system structure, then we will see file system implementation, then how we can implement different kinds of file system. I hope you all have heard about like FAT32, NTFS or basic file systems. Okay, so then we will see directory implementation, how we can implement the directory, and after that we are going to see this allocation methods. What are those allocation methods, that how the files are allocated to the free disk space, we are going to see in this lecture. Then we will see free space management, like for example if some file has been completed their execution and now that space is free, then how to allocate that space to some other new file. Okay, and then we will see efficiency and performance and how we can recover a file if some failure or if some fault has happened. So what is a file system structure? A file system provides efficient and convenient access to the disk by allowing the data to be stored, located and retrieved easily. Okay, so a file system possesses two different design approaches. Let's see those design approaches. The first problem is defining how the file system should look to the user. Means if we are dealing with a file system, how the file system is when we are seeing that file system from the user's point of view, how the file system is going to look from the user's point of view. The next point is this first problem is this task involves defining a file and its attributes, the operations allowed on a file and the directory structure for the organizing file. Okay, the second problem is creating algorithms and data structure to map the logical file system onto the physical secondary storage devices. Okay, so this is the second problem. The second problem is to create algorithms and data structures to map the logical file system onto the physical secondary storage devices. Okay, so the file system itself is generally composed of many different labels. So we are going to see those different labels in the next this slide. So you can see these are the layered architecture, where in this layered architecture you can design you can just consider your file system is divided in two. So first is your application programs. This is the where users run their programs, and after that this is your logical file system. We will see in details in the next slide about all these layers. Then file organization module, then basic file systems, and this is your lowest level, which is your IO control and the devices. Okay, so let's see what we will start from the very lower level, that is your IO control. So this consists of device drivers and interrupt handlers. So we will see what are these interrupt handlers in our next lecture, that is your IO systems, input output system. So an IO control layer consists of a device drivers and interrupt handlers to transfer information between the main memory and the disk system. Okay, so interrupt handlers are used, and that will be more clear when we will cover up the next lecture, that is your IO input output subsystems. A device driver can be thought as a translator. Okay, input consists of high level commands such as retrieve block 123. So when this input consists of high level commands which are understandable to human, like it is basic English, like you can see retrieve block 123 from some pointer location. Output consists of low level hardware specific instructions, or you can say a machine language or assembly language, that are used for the hardware controller which interfaces the IO devices to the rest of the system. Now the next layer is your basic file system, which issue generic commands to the appropriate device drivers to read and write physical blocks on the disk. It manages memory, buffer and cache. Okay. File organization module. File organization module is responsible for understanding the type of file, its logical address and physical address blocks. It translates logical block number to physical block number. So it manages free space and disk allocation. So what is the responsibility of file organization module? Mainly it manages the free space and disk allocation, and it's do all the mapping in between this logical block number and into physical block number. Okay, now the next layer is your logical file system, which generally manages the metadata information. The metadata means metadata information is the data, it's the information about the data without the content of data. Okay, so metadata is not the content of the data, it holds only the information about that particular file or data. Okay, so translates logical file system is responsible for translating file name into file number, file handle, location by maintaining file control blocks, FCB. Okay, like in nodes in Unix are there. Directory management is also done by this logical file system. Okay, and provides protection and security. It provides logical file system also used to provide protection and security. Use of layering include the decision use of layering including the decision about how many layers to use and what each layer should do is a major challenge, is a major designing issue, and which is an overhead, because you have to again and again think that while implementing a file system, how many layers are you going to use, you have to think and think this again and again. So this can be a overhead, this can be a challenge. Okay, so layering is useful for reducing complexity and redundancy, but adds overhead and can decrease the performance also, because you are dividing all the modules into layers. So structures and operations used to implement file system operations are, there are two types generally. First is your on disk file system implementation, and another view is your in memory. Okay, so when we talk about this on disk file system implementation, so how this can work? So this ones have boot control block. This contains info needed by system to boot operating system from that volume. So suppose you have stored your operating system in volume C drive or something somewhere. So boot control block is the one which holds what? Boot control block will holds the pointer to that volume, which will bring the operating system which will load the operating system into the main memory. So this contains info needed by the system to boot OS from the volume. Next is, you can see needed if volume contains operating system, usually first block of volume. Okay, in Unix file system it is called the boot block. In Windows NT file system, which is also known as NTFS, it is known as partition boot sector. Now the next type of block is volume control block, or this is also known as super block or master file tables. So this contains volume details, means the partition that you have to use. So total number of blocks, comma, number of free blocks, block size, free block, pointers or array, all comes inside this volume control block. In Unix file system it is called as super block, and in NTFS it is called as master file table. Now the third point is directory structure directory structure. that organizes the files. Okay, in Unix file system, this includes file name and inode numbers, inode numbers, and in NTFS it is stored in master file table. Okay, per file control block FCB, per file control block contains many details about the file, such as inode number, permission, size, dates. NTFS stores into master file table using relational database structures. Okay, when we talk about this in-memory file system implementation, this in-memory file system file system implementation contains an in-memory mount table which contains information about the mounted volume. Okay, and in-memory directory structure cache holds the directory information of recently accessed directories for directories at which volumes are mounted. It can contain a pointer to the volume table. Okay, the system wide open file table is used to contain the copy of the FCB of each open file, whatever the file are, whatever files are open. So those open files are kept in this system wide open file table. The per process open file table contains a pointer to the appropriate entry in the system wide open file table as well as other information. Buffers hold file system blocks when they are being read from disk or written to disk. Now let's see about directory implementation. What are the ways that we can implement the directory? So there are two ways. First is your linear list and another is your hash. Okay, so what is this linear list? This linear list will maintain a list of file names, linear list of file names with pointers to the data blocks. Okay, this is very simple to program also, and time consuming to execute, because you have to do it linearly, so linear time will be taken. Okay, so you can see linear search time is there, and could keep ordered alpha. So to just reduce the time, there are ways like you can keep ordered alphabetically, okay, or via linked list, or you can use B plus tree also. Next is your hash table. Hash table is the linear list. You have to implement linear list with the hash data structure. Okay, so benefits of using this hash table is it decreases directory search time, and then it may have a collision situation when you are using a hash table, that is situations where two file names hash to the same location. Okay, so only good if entries are fixed sized or use chained overflow method. So now we are going to see several allocation methods. What are those allocation methods? Okay, so what does this allocation means? An allocation method refers to how disk blocks are allocated for files. So you have already seen disk structure, you already know about the platters, you already know about the tracks in on the hard disk. So how those tracks, how those sectors, how those platters will be allocated to different files. So for that we study these different allocation methods. Okay, so let's see, there are several methods inside this allocation method. First is your contiguous allocation, where each file occupies set of contiguous blocks. Okay, so you can see this is an example. Here you can see this is the file which are having their starting length, starting address, or you can say starting pointer, and the length of the file. So you can see this count is starting from 0 and taking 2 file size. So two contiguous blocks 0 and 1 has been given to this count. Similarly, this TR is starting from 14 and its length is 3. So you can see the TR is stored in 14, 15, 16 because its length is 3. But it can, in this contiguous, we can allocate the memory into contiguous manner, means it should be in continuous manner. Okay, disk addresses define a linear ordering on the disk. best performance. This contiguous allocation gives best performance in many cases. Okay, simple only starting location like block number and length like number of blocks which are required is required in the while using this contiguous allocation method. Okay, problems include finding a space for files, knowing file size. Okay, so these are the problem that a contiguous allocation faces. What are those problems? A programmer might not be aware of how much the space is needed for the file when the file will run. Okay, problems including finding a space for file, knowing file size in advance. External fragmentation also can happen. You might be knowing this internal and external fragmentation from memory management. So external fragmentation can also occur in this. Need for compaction, either you can use offline downtime or online compaction you can do for removing this external fragmentation. Compaction means just to shift all the files onto some either top or to the bottom to remove the free space in between. Okay, so the next allocation method is your linked allocation. What is this linked allocation? Each file a linked list of block. Each file is a linked list for a block. So file ends at nil pointer. So you can see here is a file which is starting from this location 9 and ending at 25. So you can see this, where is 9, here is your file is starting, 9 is keeping the file also as well as pointer to the next node. Pointer to the next node is also available. Like suppose if this file node is having 512 KB and pointer is taking 4 KB. Okay, so only 508 KB will be visible to the user. The user can use only 508 KB because it is containing 4 KB as a pointer to the next node, which is your 16, then 1. Okay, the 16, then 1, then 2, then this is your 25. Okay, 25 is containing the nil pointer. Okay, so no external fragmentation in this in linked allocation, and each block contains pointer to the next block. Each block contains pointer to the next block. No compaction as because no external fragmentation is there. Free space management system called when new block needed. Okay, improve efficiency. This model improve efficiency by clustering blocks into groups but increases internal fragmentation. Internal fragmentation can happen in this linked list allocation method. Reliability also can be a problem because if any node fail, then the link will be broken. Locating a block can take many input output and disk seeks. Okay, locating a block can take many. So suppose if you want to locate a block 14 which is in the way in between, so to find you have to go and you have to start from the very beginning. Okay, if each block that I have already explained, if each block is 512 bytes in size and a disk address or the pointer requires 4 bytes, then the user sees block of only 508 bytes because the rest is used for the pointer to the next node. Now the next allocation method is very easy. We have also seen this in access method also. This is your indexed allocation. What is this indexed allocation? So each file has its own index block. Each file has its own index block of pointers to its data block. So what you are doing, you are just maintaining an index that will contain the pointers to all the nodes which are free for allocation. Okay, so you can see this is your index, this is behaving like an index. Okay, so indexed allocation, you can see this node 19 is behaving like an index to different nodes 1. Okay, 1, 10, 9, 16, 25. Okay, so this 19 is behaving like an index node which is containing the pointers to the different nodes that will be required. Okay, this needs index table random access is used. Random access can happen because while you seeing this index table, you can go directly on any of the file block. Okay, no external fragmentation, but have overhead of index block, because you have to keep the index into the memory also. So now we will see a few techniques that are your free space management. So free space management, when we talk about free space, there are these are the free spaces in between which cannot be used by the other files. So we have to manage these free spaces. So there are few techniques that we are going to study. The first one is your bit vector. Okay, so what is this bit vector? Each block is represented by 1 bit. Okay, and if the block is free, the bit is the block 1 bit means either 0 or 1. So if the block is free, the bit is 1. Okay, and if the block is allocated, the bit will show as 0. Okay, so there is the one example that I have taken. You can see 2, 3, 5, 4, 5, 8, 9, 10, 11, 12, 13, 17, 18, 25, 26 and 27 are free, and the rest of the blocks are allocated in the above diagram that we have seen in the previous slides. Okay, so how we will represent in this using this bit vector? It is 0 0, which means you can see these blocks are free, like 2, 3, 4, 5. So 2, 3, 4, 5 is showing 1, and this 0 0 is not free, means 0 and 1 locations are not free. So this is very easy. Advantages are its relative simplicity and efficient in finding the first free block or n consecutive free blocks on the disk. Next method is your linked list method. So how we can manage the free space using this linked list? You can see another approach to free space management is to link together all the free disk blocks, keeping a pointer to the first free block. Okay, in a special location on the disk and caching it in memory. Okay, so you can see free space is linked together all the free disk blocks. So you are linking all the free. So all the free block is storing the pointer of the next free block. Okay, so 4 is storing the pointer of 5, 5 is storing the pointer of 8, 8 is storing the pointer of 9. Okay, so this is the linked free space management. First blocks contains a pointer to the next free disk block and so on. Okay, so cannot get contiguous space easily while using this. No waste of space happens in this way of free space management. And the next is your grouping. What we do in grouping, this is similar to what we do in a linked list, but you can see modify linked list to store address of next n-1 free block in first free block. So in linked list, what we were doing in linked list, we just simply linking all the free nodes and keeping the pointers of the next free node into the previous one. Okay, but here we are keeping the address of all the n-1 free blocks into the first block. Okay, so if suppose 2 blocks are further are empty, okay, so this will contain all the address of both the free blocks. Okay, now the next is counting. What is this counting? This counting because space is frequently contiguously used and freed. With contiguous allocation extents or clustering, so it just maintains the count of the free block. Okay, keep address of first free block and count of following free block. Okay, so it contains the address of first free block and it maintains the count of the number of free blocks that are available inside the disk. Keep free space list then has entries containing addresses and counts. Now we are going to see different efficiency and performance. What are these efficiency on which what are those points on which efficiency depends? So, these are generally disk allocation and directory algorithm, types of data kept in file directory, pre-allocated or as needed allocation of metadata structures, fixed size or varying size data structures. Now, the performance, on what points performance depends of a file system implementation. Let us see. Keeping data and metadata close together, okay, will increase the performance. Use of buffer cache, like separate section of main memory for frequently used blocks, you can maintain to increase the performance. Synchronous writes, sometimes requested by apps or needed by OS. No buffering caching, writes must hit disk before acknowledgement, okay. And asynchronous writes more common, bufferable faster, okay. So, we just try to do the asynchronous writes more common, okay. Next is your free behind and read ahead technique to optimize sequential access. If you want to optimize the sequential access method, you can use these techniques like free behind and read ahead, okay. And reads frequently slower than writes. So, on these points the performance of a file system depends. Now, the next and the last topic is your recovery. So, what is this recovery? How we can recover a file, that has if some fault has happened on your disk. So, the first way is to use this consistency checking. Consistency checking, what does this do? Comparing data in directory structure with data blocks on disk and tries to fix the inconsistencies, okay. So, this performs comparison again and again. It just compares data in directory structure with the data block on disk again and again, okay, to try to check for the inconsistency. Can be slow and sometimes fails also. So, the next method is your backup and restore. So, use system programs to regularly take backup of data from disk to another storage device. Either you can use a magnetic tape or magnetic disk, optical, any one. Just take the backup, and this can help you recover lost file or disk by restoring data from the backup. Another way is to use log structured file system. So, log structure file system provides us what? A transaction is considered committed once it is written to the log. So, logs are maintained sequentially, sometimes to a separate device or separate disk. If the file system crashes, all remaining transactions in the log must be performed, okay. Faster recovery from the crash, remove chances of inconsistency of metadata. So, that is all for this lecture. We will again see IO subsystems, IO systems and IO buffering in the next lecture. Thank you.